Hello, grade 9. Let's meet again. This video will continue also the geometry. This is the third lesson in Unit 5. The inscribed angle suspended by the same arc. We took last time the difference between the inscribed angle and the central angle. And we said that the inscribed angle is the angle in which its two sides, its two chords in the circle, and the vertex is on the circle, and they are suspended by an arc. But the central angle, it is the angle in which its vertex is the center of the circle, and the two sides of the angle is two radii inside the circle. Okay, today we will talk about, and we said the relation, and the second lesson was the relation between the central angle and the inscribed angle, and we said the measure of the inscribed angle is half the measure of the central angle suspended by the same arc. They must be suspended by the same arc, not an inscribed angle like this and a central angle like this one. Okay? Okay, our lesson today is about inscribed angles that are suspended by the same arc. Our theorem says in the same circle the measures of all inscribed angles suspended by the same arc are equal. And that's why, because if I have a circle like this one, and I have many inscribed angles like this angle, and this is another angle, and this is another angle. For example, there are three angles. Okay? Okay, if I call this one E, and this one, for example, D, C, A, and B. Okay, and I said that, for example, that measure of angle C, if I want to get measure of angle C, it will be half measure of angle AB arc. Why? Because also we said before that the central angle, the measure of the central angle equals the measure of the arc suspended by it. So here, if this is M, so measure angle M equal measure of angle, for example, AB arc. So measure of the central angle or the measure of the arc suspended with this inscribed is equal double the inscribed one. So measure angle C as it is inscribed angle equal half measure arc AB. If I want to get measure angle D, it is also, this is the arc of the inscribed angle, this is the angle, so it is equal also half measure of arc AB. And if I want the last one, for example, measure E, this is the angle, and I want to get this one, so this is equal half measure of angle F arc, sorry, B. So measure of angle, all of them equal measure half measure AB, half measure arc AB, half measure arc AB. So measure angle C equal measure angle D equal measure of angle E. There is a corollary say that in the same circle or any number of circles, the measures of the inscribed angle suspended by the same arcs are equal measures by arcs of equal measures are equal. Okay, some notes here. In circle M, as we see, we are not suspended by the same arc, but given that I have two equal arcs, measure arc AB equal measure arc CD. So the inscribed angle suspended by arc AB equal the inscribed angle suspended by the arc CD. In this case, the length, if you remember the length, what is the length? We said that the measure of the arc equal the measure of the central angle. But if I want the length of the arc equal the measure of the arc, which is AB, divide 360 times 2 by r, the circumference of the circle. So in this case, the circumference of the circle is equal because it is the same circle, so the length of arc AB equal the length of arc CD. Here, another note, if M and N are two congruent circles, and given that measure angle AB of arc AB equal measure of arc CD, then also the inscribed angle suspended by arc AB equal the angle Y which is suspended by the arc CD. Also in this case, the length of arc AB equal the length of arc CD, because the radii of the two circles are equal because they are congruent circles. What about in any two circles like M and N? They are not congruent, they are two different circles. Measure AB arc equal, if measure AB arc equal measure of CD arc, then measure X equal measure Y. But in this case, the length of arc AB doesn't equal the length of arc CD. And why? Because the measure of the arcs are equal. Yes, we said that it is equal the measure of the arc divide 360 times 2 by r. Why the measure of the length of the arcs are not equal? This part equal in both of them, but here the radius is different. Radius of circle M is different than the radius of circle N. That's why the length of the arc doesn't equal the length of the arc. Also, I have a converse for the previous corollary as true also, which says in same circle or any number of circles, the inscribed angles of equal measure suspended arcs of equal measure. Okay, so I have corollary and I have the converse of the corollary. Okay, okay, let's move to some drills. Study each of the following figures, then complete. Here I have to get measure angle C. Measure angle C. I will look at any inscribed angle suspended by the same arc. So here measure angle C suspended by the arc BD. So I have another angle which suspended by the same arc, which is measure angle A. So C will be equal 50 degrees. Okay, what about measure of angle B? He want measure of angle B equals what? Measure of angle B, this angle. He gave me that D equal 25. So also measure of angle D will be 25. Why? Because if I looked at measure angle D equal 25, this is the arc and AB is suspended by the same arc, so both of the two inscribed angles are equal. Okay, let's move to number 2. Study the figure very well. What do we have here? You have here AB equal AD. This is an isosceles triangle. So from this part you will find that this angle, angle B, all equal 70 degrees. Okay, first you want measure of angle C. Okay, measure angle C equals what? Measure angle C, this is measure angle C. In order to see the arc, it is suspended by arc BD. So another angle which suspended by the same arc, which is A. I don't have A, but I can get it because in triangle ABD, this angle is 70 and this angle is 72 base angles in the triangle. So the vertex angle will be 180 minus 140. So this part will be 40 degrees. So measure angle C will be equal to measure angle A equal 40. What about measure of angle BDC? Where is BDC? BDC, this part, this small one, equals what? BDC. No, BDC, yes. No, sorry, BDC. Okay, this part is 70. I want what? To get BDC, I want the small part. The small part equal what? Excellent. The small part equal to angle ABC. If you looked at the blue one here, the arc is AC and ADC suspended by the same arc. So this part is 20. So this part will be 20. 20 and 70 equal 90. Let's study this figure. I have measure A 43 and I have measure C 20. He want B, E, D, this part. Yes, excellent. It is equal to 20. Why it is 20? Because measure BCD and measure BED are equal because they are suspended by the same arc BD. What about ABE, this angle? Let's erase this one. I want to get ABE. this angle. We got this 120. And in this triangle, I have 20 and I have 43. You can get the third angle by subtracting 120 minus the sum of 43 and 20. You will have 117 degrees. Okay, I want to study these figures also. As we see, we have the same circle, and given that these two arcs are equal, the measure of the two arcs are equal, so the inscribed angle opposite to the equal arcs are also equal. So 5x minus 40 will be equal 30. Then 5x, take 40 to the other side, equal 70. Then x will be 70. 70 divided by 5 equals 14. 70 divided by 5 equals what? 14. So angle, so x equal, he want x, so x will be equal to 14. What about this one? I have BED 3y minus 5 and he want y. I have the measure of the arc AC 50 and I need y. How can I get y? Look at the givens. I have a very important given here, which is the parallelism. We studied before that if I have two parallel lines inside the circle, two parallel chords, these are chords in the circle, so the measure of the arcs between the two parallel chords are equal. So the arc BD will be equal to the arc AC equal 50. So the angle opposite to it, the inscribed angle, will be also equal. Okay, but equal to what? I have got this 150, so the inscribed angle will be equal what? It's not equal the measure of the arc. It will be equal half the measure of the arc, because the measure of the arc equals the central angle and the inscribed equal half the central. So 3y minus 5 will be equal half the measure of the arc, which is 25. So 3y equals 25 plus 5 equals 30. So y will be 10 degrees. Okay, so y equals 10. What about this figure? I have A, B, C, 2z plus 6, and I have a small angle, angle E in the small circle 56, and he wants z. Please, you must look at the circles very well. You must, the theorems, study them very well. All the theorems that you took before, not only for this lesson. Okay, okay, if I looked at the small circle first, this is small circle. They are concentric circles. They have the same center. In this circle, this angle is inscribed angle. Okay, and its central is this one. So this is the central angle, suspended. This is the arc, and this is its inscribed. So this inscribed angle equal half the central. So the central, if I need it, I will get it 112. 156 times 2 equal 112. Let's see. So the central angle here equal 112. If you looked at the big circle now, if you look at the big circle, you will find that this is also the central angle for the big circle, because they are concentric circles. And the inscribed angle is CBA, and they are suspended by the same arc. So this angle is 112, so this inscribed angle also will be half 112, so we'll find that this inscribed angle equal 56, and without getting the central, it's the two inscribed angles will be equal because they are concentric circles. So this angle equal 56, so we'll make the equation 2z plus 6 equal 56. Take 6 to the opposite side with difference, so it will be 2z equal 56 minus 6 equal 50. So z will be equals to 25 degrees. Okay, see, this is an example as proof. They are so easy, by the way. In the opposite figure, AB and CD intersect at point E. EA, this part only equals to ED. So these two sides are equal. Prove that EB, I want to prove that EB equals to EC. Okay, so I didn't have anything about the sides. I would think about the angles to prove that these two angles are equal. So let's see the angles. What can I get from the angles? First, you have what? You have isosceles triangle. So as AE equal ED, so measure D equal measure A, right? Okay, this is number one. Measure A equals measure D because isosceles triangle. What about if you took this arc? Angle DAB equal angle DCB suspended by arc BD. So angle A equal to angle C, right? This is number two. Let's look about the other one. If I looked at from the other side, measure of angle D will be equal to measure of angle B because they are two inscribed angles suspended by arc AC. So measure of angle D will be equal measure of angle B. This is number three. As you see here, measure A equal measure D and measure A equals measure C. So D and C will be equal. And also measure D equal measure B. So B and C are equal. So EB equals to EC. Okay. Another example. I have here AD and EB are two equal chords in length in the circle. AD intersect BE at point C, which is outside the circle, and I want to prove this small part, this small one. I make it bigger a little bit. This is small part ED equal to EC. Okay, what can I do here? Okay, as I have EB equals to DA, two equal chords, what you will deduce here that the measure of arc EB equals the measure of arc DA. This is one of the theorems we took. Okay, by adding this small part, the measure of ED to both sides, you will find that measure of arc DB all equal what? Measure of arc ED all will be equal to what? To measure of EA, or it will be called DEB will be equal to EDA. Okay? Okay. Okay. As this one, which angle is opposite to it? The arc, the red one. This arc. Okay. The red one, it is opposite to B. And the blue one, you know, DEB, all this one, it is opposite to angle, as you see here, angle A. Okay, given that these two chords are equal, right? So measure A equal measure B, and this triangle as measure A now equal measure B, so the whole side it will be becomes an isosceles triangle, so BC all will be equal to CA all. By subtracting the two equal chords, you'll find the small part equal the small part. So again quickly, this one, I have two equal chords, EB and DA. So when the two chords are equal, the opposite arcs will be equal. By adding this small part to both sides, so we'll find that measure of DEB arc equal to measure of EDA arc. The angle opposite to DEB is angle A. So now angle A equal to angle which is opposite to the arc EDA. This one equal to this one. A equal to B, base angles. So where is the isosceles triangle? Isosceles triangle is this one. So now CA all equal to CB all. And since the two chords are equal, subtract the two chords, so this part will be equal to this one. Okay, look at this one very well. I'll make it also bigger. I have M and N are two intersecting circles at A and B. AC intersect the circle M at C and intersect the circle N at D. AE intersect circle M at E and circle N at F. Prove that EBC equal to FBD. Wow. You'll tell me, miss, they are so far from each other. And this is in a circle and this is in another circle. Okay, let's see what I will have from the first one and what I'll have with the second one. Look at this circle first, the small one. Try to study it very well. You will find that we took what that we have. If I have two inscribed angles suspended by the same arc, they are equal in measure. So look at it. You will find that measure CBE equal to CAB, CAE. Why? If I call this one and this 2, measure 1 equal measure 2. Why? Suspended by the same arc CE. Okay, let's look at the second circle, which is this one. Also, if you look at it very well, you will find that FAE will be equal to angle FBD because they are suspended by the same arc DF. So angle, for example, 3 equal angle 4. So measure angle 3 equal measure angle 4. Okay? Okay, still I didn't get anything. I want 2 to be equal to 4. And here 1 equal to 2 and 3 equal to 4. Look at this two sides, this 2, 1. You will find that DC intersect FE at point A, right? So angle 3 equal to angle 1 vertically opposite angle. Angle 1 equal angle 3 vertically opposite angle. So when 1 equal to 3, so 2 will be equal to 4, which is the required to prove. Okay, another drill. In the opposite figure, AB and CD are two equal chords. AB and CD are two equal chords. AB intersects CD at E. Prove that the triangle ACE is an isosceles triangle. Okay, isosceles means I want, if possible, to get that these two angles equal in measure. So it becomes an isosceles triangle. So AB chord equal DC chord. So AB chord, the opposite arc is ADB. So arc ADB equal, where is DC? DC is this one. It is equal to arc DBC. As you see here, DB is common between the two arcs. So I can subtract the measure of arc DB from both of them. So the remainder is measure of arc AD will be equal to measure of arc CB. Where is the inscribed angle opposite to this one? These two arcs become equal. Okay, so equal in one circle, the opposite inscribed angles are also equal. So this is opposite to CB arc and this is opposite to AD arc. So the two angles are equal. So the triangle is an isosceles triangle. The last drill, and you will finish the first part of our lesson. AB equal to AC. E belongs to arc CB. It is not the diameter and it's not passing through the center. I want to prove that measure AEB equal measure AEC. This is only two steps. Only two steps. Since AB chord equal to AC chord, so measure AC will be equal to measure AB. Now, since AC equal AB, therefore measure AC arc equal measure AB arc. two arcs in the same circle are equal, so the opposite inscribed angles are equal, and that's it. Okay? Okay. What next? This is the converse of our theorem, and that's the last part in our lesson today. If two angles subtended by the same arc, by the same base, and on the same side of it, it have the same measure. Sorry, I have, I think the previous video and this video I saying suspended. I don't know why, and it is subtended. Okay, sorry for this mistake. So it is subtended by the same arc, not suspended. I don't know from where I get this word. Okay, of two angles subtended by the same base and on the same side of it have the same measure. Then their vertices are on an arc of a circle and the base is a chord of it. What does this mean? Okay, this means that if I have here, like this one, if you look at this one, if I have measure angle D and angle C are both drawn on base, as you see this base, don't look at the circle now. If I have a base AB and I have draw angle C and angle, for example, D, okay, and measure C equal measure D, then the points A, B, C, D lie on one circle. They will both, with the four points, will lie on the same circle, and AB will be a chord in it. Okay, but the two angles must be on the same side of this chord. Okay, not on different sides. Okay, so let's see the example. AB, this is A, B, C, D. Measure C 50. AB equals to AD. Measure A equal 80. Measure A all. I want to prove that the points A, B, C, D have only one circle passing through them. Okay. Okay, as I have in triangle, if I look at triangle BDA, you will find that AD equal to AB, then measure of angle B equal measure of angle D. These two angles are equal, right? Okay, so since measure of angle A equal 80 and these two angles are equal, isosceles triangle, to get the base angle 180 minus 80 divide by 2, so each part will be 50 and 50, because 180 minus 80, 100 divided by 2 equal 50. Since measure angle D and measure of angle C, as we see that they are equal, which is 50, and they are both drawn on the same base AB. As you see, they are from the same base AB, and on one side of it, not on different side, the next angle not the other side, both of them on the same side of AB. So ABCD have one circle, and AB will be, if I draw a circle, AB will be a chord inside the circle. So from where I know that they are having one circle, because we said that the converse of the theorem, if I have two equal angles and they have one base, and this is the two angles are coming from this base on one side of it, so it's only one circle passing through it. Okay, this is the last drill I have. Which of the following figures can have a circle passing through the points A, B, C, D, and which is not? If I found two angles with the same side and on the same side of one of the sides, so it has one circle. It has one base, the same base. So I must try to get angles if they are equal or not. For example, if I will look at the base CB, if I found that measure A equal measure D, so they will have one circle passing through them. And if I looked at the side D or the base DC, if you found this angle and it is 38, so the two angles will be on the same base and on one side of it, so it has one circle. Let's see, can we get angle A or any other angle or not? Okay, measure what I have here. I have what I have in the figure. I have parallelism. Of course, I will use the parallelism. Uh, Angle, which angle equal? Okay, this is parallelism. This is letter Z. Okay, so this angle will be 38. Can you get this angle? Yes. 76 is exterior angle or angle DEC, exterior angle for the triangle AED. So angle DAC will be 76 minus 38. So it will give you 38. Since DAC and DBC, sorry, equal 38, and they have the same base DC and on one side of it, so it will have one circle passing through it. Another one will say, Miss, I can get it by the supplementary angle. Yes, you can complete this one and get 180 minus 76 to get this angle, and then by the interior angles of that triangle you will find it. This one will be 104, then 180 minus 104 plus 38, it will give you also 38. The next one, okay, I have two equal sides, so these angles are equal. Look at any of them. This is 25, so if you can get this one 25, it's if not 25, so there not be a circle passing through it. This is 60, so if you get this one 60, okay, if not. So let's think. I have this equal. First I have to get what? Maybe you will get this 25 and this is 85. You can get this part. Yes, you can get it by supplementary angle. So it will be, this part will be 180 minus 85. This part will be 95. This is an isosceles triangle. 180 minus 60, it will give you what? Not 60. 180 minus, okay, let's see again, because 60 is not at the part. So sorry again, okay. This is part, I said this is, yes, 95. No, I can get here, from here I can get measure DAC. So it will be 180 minus what? Minus 95 plus 60. So 180 minus 155, the sum of them. So this small part is 25 in this triangle. I calculated the angle from this triangle. This is an isosceles triangle. Both of them are equal, so the base angles are equal. So this is also 25. So now I have angle DBA equal to angle ACD having the same base DA. So they will have one circle passing through it. Okay, if this one, for example, you calculate it and you find it at 30, so you will not have a circle. The third one and the last one, this is EB equal to EC. So angle C equal to angle B in this triangle. We have parallel DA parallel to CB. So letter Z, measure A equal to measure C, and also letter Z from the other side and the other transversal, which is now DB. So this angle will be equal to this angle. So since B equal to C and A equals to C and D equals to B, so both A and B will be also equal, and they are with the same base DC. So also this one having one circle passing through it. This is our lesson, and of course I have exercises, exercise for the lesson, exercise 5.3 on your book on page 105. Please try to solve it. Sorry again for the mistake. It is subtended by the same arc, not suspended. So subtended by the same arc. Sorry if the two videos are with suspended. Hope you benefit from it, and hope that you will watch the video and concentrate in it. See you next time, and thank you. Grade 9.